Welcome to this class. In this class, we are going to learn about the industrial manufacture of sulfuric acid. We find that industrial manufacture of sulfuric acid is by a process referred to as the contact process. For the contact process, it is referred to as the contact process. For the contact process, we have raw materials and we have the conditions that are necessary for this process to proceed. For instance, the raw materials for this process, we have three raw materials. The first one is water. Secondly, we have sulfur. And finally, we have air. So for this process to proceed, we must have these raw materials for us to produce sulfuric acid. Now, we move to the next part, which is the conditions necessary for the contact process to proceed. The conditions necessary, we have three conditions. The first condition, we must have a temperature of 450 degrees Celsius, and also we must, for air to react with sulfur, there must be presence of a catalyst. So the condition will be presence of a catalyst, which is referred to as the vanadium 5 oxide. So the conditions are a temperature of 450 degrees Celsius. Secondly, we have a presence of a catalyst. Presence of a catalyst. In our case, we have two catalysts. We either use platinum catalyst or vanadium 5 oxide. You find that vanadium 5 oxide is most preferred to platinum. Reason being, vanadium 5 oxide, it is cheap and also it is not easily poisoned by impurities. We have the final condition, which is a pressure of 2 to 3 atmospheres. These are the three conditions that will enable the contact process to go on. Now, from the conditions, we now move to the steps of the whole contact process. The first step is the burn. In the burner, sulfur is heated in presence of air to produce sulfur 4 oxide gas. So here the equation will be sulfur solid plus oxygen, we get sulfur 4 oxide gas. This one is a gas. Now, after production of sulfur 4 oxide from the burner, the gas, which is sulfur 4 oxide, with air, is then pumped to the next chamber, which is the cleaners and the dryers. In the cleaners and the dryers, the mixture of air, that is sulfur 4 oxide and air, is purified. So purification in this stage proceeds in this manner. In the cleaners, dust particles are removed from the mixture through electrostatic precipitation. Then after that, the mixture is then pushed to the dryers. In the dryers, the gas is passed through concentrated sulfuric acid. That is to remove the water droplets that are present in the mixture. After the cleaners and the dryers, we move to the third step, which is the heat exchanger. In the heat exchanger, the mixture of sulfur 4 oxide and air is heated to a suitable temperature. So after heating to a suitable temperature, the mixture is then pumped to the catalytic chamber. In the catalytic chamber, the temperature here, is raised to 450 degrees Celsius. When this temperature has been attained, the mixture of sulfur 4 oxide and air are then passed over a catalyst, which in our case is vanadium 5 oxide. So when the mixture is passed over vanadium 5 oxide, there will be production of sulfur 6 oxide. The equation will be sulfur 4 oxide gas plus oxygen gas. We will have sulfur 6 oxide. Now, we have to balance an equation for it to be referred to as a chemical equation. Here we put 2, sulfur will be 2, then we put 2 here. So sulfur is 2, oxygen 4 plus 2, 6. This is 2 times 3. Oxygen is 6. So there we can see that the equation at the catalytic chamber will be this one. Now, after production of sulfur 6 oxide, the gas is pumped back to the heat exchanger. In the heat exchanger, the air is then cooled. That is, sulfur 6 oxide is cooled in the heat exchanger. Then now, after cooling, it is pumped to the absorption tower. In the absorption tower, sulfur 6 oxide is reacted with concentrated sulphuric 6 acid for us to obtain what is referred to as oleum. In this process, we don't dilute sulphuric 6 acid, we don't dilute sulfur 4 oxide over water because the reaction will be exothermic, leading to production of a lot of heat, which may boil the acid to form mist, which is poisonous to the environment. Now, the equation at the absorption tower is sulfur 6 oxide gas with concentrated sulphuric 6 acid. We obtain oleum, which is in this manner. Sorry, oxygen. Now, the oleum produced from the absorption tower is then moved or pumped to the dilution chamber, where it is mixed with a lot of water. That is, it is diluted with a lot of water for us to obtain concentrated sulphuric 6 acid. And in summary, we can develop what is referred to as a flow chart for the whole contact process. So the flow chart will be in this manner. Here we have the burner. Here we have air. Then we have sulfur. Then from the burner, we move to the next chamber, which is the cleaners and the dryers. So the equation for the burner will be sulfur plus oxygen. That is a solid plus this one gas. We obtain sulfur 4 oxide. So here, sulfur 4 oxide and air is pumped to the cleaners, where it is purified using a method which is referred to as electrostatic precipitation. That is to remove dust particles. We remove dust particles through electrostatic precipitation in the cleaners, and in the dryers we remove water droplets by passing the gas through concentrated sulphuric 6 acid. Now from this part we move to the heat.
From there
we move to the heat exchanger. In the heat exchanger, the mixture of sulfur 4 oxide and air is preheated to attain a suitable temperature. Then from here, the gas is then pumped to the catalytic chamber. This is the catalytic chamber. Here in the catalytic chamber, sulfur 4 oxide and air, the temperature is raised up to 450 degrees Celsius. So the temperature here is 450 degrees Celsius. Then the gases will then be passed over a catalyst, which is vanadium 5 oxide. That will lead to production of sulfur 6 oxide. The equation will be sulfur 4 plus oxygen. We get sulfur 6 oxide, which is a gas. Now the sulfur 6 oxide is then pumped back to the heat exchanger. This is hot. Sulfur 6 oxide is pumped to the heat exchanger, where the gas is then cooled to a suitable temperature. From the heat exchanger, the gas is then pumped to the absorption tower. In the absorption tower, the gas is mixed with concentrated sulphuric 6 acid to produce what is referred to as oleum. So the equation that leads to production of oleum will be sulfur 6 oxide plus concentrated sulfuric 6 acid. We obtain oleum, which is now we obtain oleum. When oleum has been obtained, it is then pumped finally to the final chamber, which is referred to as the dilution chamber. In this chamber, which is referred to as the dilution chamber, oleum is diluted with a lot of water to produce concentrated sulfuric 6 acid. So here the equation will be oleum, which is there this way, plus water. We obtain concentrated sulfuric 6 acid. I'm going to balance that one, to put it that way. So here, the final product here will be sulfuric 6 acid. And I've said that in contact process, we do not mix sulfur 6 oxide directly with water. Reason being, it produces a lot of heat. That is to say that the reaction between water and
sulfur 6 oxide
is exothermic. And if the reaction is exothermic, you find that the excess heat produced will then boil this concentrated sulfuric 6 acid to form mist, which is poisonous to the environment. Please like and comment.